so this was the graphing piecewise homework we did the other day. So I'm going to go through and work through a couple of these. I guess all of them really, just so you can kind of see anything that you missed in class. So we're going to start with the graph. All right, so on the graph, I'm going to look at my two different rules. I'm going to create a table for each one. So I'm going to start with the x plus 5. So I'm going to make a t-chart, x values, y values, and this is for the function x plus 5. All right, so the first x value is where the functions change at -2. So I'm going to evaluate what happens with this at -2. And then I need x values that are less than -2. So that would be -3, -4, and so on. All right, I'm going to take each one of these values, plug it in. -2 plus 5 would give me a +3. -3 plus 5, that's going to give us a +2. -4 plus 5, that would give us a +1. So that is the chart for the first function. I'm going to go ahead and do the chart for the other function. So again, x, y, and this is for the function -2x minus 1. Again, I want to figure out what's happening here where the functions change. So I want to know what happens at -2 for x. And then I'm going to pick numbers that are bigger than -2. So -1, 0, those will work. So we'll plug these in here. So -2 times -2 is +4. 4 minus 1, 3. Plug in a -1. -2 times -1 is 2. 2 minus 1, 1. Plug in a 0. -2 times 0 is 0. 0 minus 1, -1. So now I'm going to plot these points. Going back to the x plus 5, I have the coordinates -2, 3. So I go left 2, up 3. Since that's a less than, I'm going to have an open circle since there is no or equal to. Plot the point -3, 2. So 1, 2, 3, 1, 2. Just make a dot. And then -4, 1. A dot right there. Then I'm going to take a ruler and connect my dots. So there's the first half. And now same thing for the other function. Again, I'm going to have a point at -2, 3. 1, 2, 1, 2, 3. Now this one is going to be a closed circle. So it kind of fills in that open circle, which is fine, that happens. And then -1, 1, and then 0, -1. Then I'm going to connect those to get the other half. Okay. All right. To answer the question whether this is a function or not, you simply try and determine, does it pass the vertical line test? In other words, does your vertical line hit that graph in more than one place at a time? The answer is no, it does not. So it passes the vertical line test, which means yes, this is a function. Now we're going to evaluate the function for those specific values. So f of -2. So we're looking at the x value, -2. I'm plugging in a -2. We have to determine which one we plug it into. Well, is -2 less than itself? The answer is no. So I do not plug it into this one. I'm going to plug it into this one, which says x has to be greater than or equal to -2. So I'm going to plug my -2 into this bottom function. So -2 times -2, that's going to be +4. 4 minus 1, 3. So f of -2 is 3. Same thing with the 3. Plugging in a 3, well, 3 is bigger than -2, so I'm going to plug the 3 into this function again. So -2 times 3 is -6. -6 minus 1, -7. And then last, the -4. Well, -4 is less than -2, so I would plug it into this top function. -4 plus 5, that's just +1. And that takes care of number 1. All right, number 2. So once again, I've got two different functions, so I'm going to create two different charts. So for the first one, let's just do the 3 minus x. So 3 minus x. get some values for x and y. So here, the function changes when x is 0, so that's going to be my first x. And for this function, I use this when x is less than 0, so I need numbers smaller than 0, so -1, -2. Plug in a 0, 3 minus 0 is just 3. Plug in a -1, 3 minus -1, well, that's 3 plus 1, which is 4. Plug in a -2, 3 minus -2, minus a negative, again, that becomes plus, so 3 plus 2, which is 5. All right, for my second table, second function was 2x plus 1, and then get our chart set up. Again, I want to know what happens at 0, so my first x value is going to be 0 again. But now I need numbers bigger than 0, so 1, 2, those will work. So plug in a 0 here. 2 times 0 is 0. 0 plus 1, 1. Plug in a 1. 2 times 1 is 2. 2 plus 1, 3. Plug in a 2. 2 times 2 is 4, plus 1, 5. All right, now I'm ready to graph. So I'm going to start with 0, 3. Notice it is underlined for this function. So I would have a closed circle at 0, 1, 2, 3 right here. So closed circle for that point. -1, 4. Just put a dot. -2, 5. Put a dot to keep up with it. Connect those points. Get that. For the other one, I'm going to plot these points. So first point's at 0, 1. There is no underline under the inequality, so this will be an open circle at 0, 1. So open circle at 0, 1. The next point is at 1, 3. And then our third point is at 2, 5. Connect those. There is your graph. Once again, does it pass the vertical line test? At no point does your vertical line hit either part of the graph more than once at a time. So it does pass the vertical line test. So it is a function. Now we're going to evaluate at f of 0, f of 2, and f of -3. So again, the x I'm plugging in is 0. So that would fall under this, where x is less than or equal to 0. So plug in a 0 here. 3 minus 0 is just 3, so f of 0 is 3. F of 2, well, 2 is bigger than 0, so I plug into this bottom function. 2 times 2 is 4, plus 1, 5. -3 is less than 0, so I would plug the -3 here. So 3 minus -3, those negatives become a positive, so 3 plus 3, which is where we get 6. All right, number 3. So here I have two functions again. This is the special case. Basically, this is the equation y equals -3. We discussed what that looks like on a graph. Y equals a number is simply a horizontal line going through the y-axis at that number. So -3 on the y-axis is right here. So it would go through that point on the y-axis. But this only picks up when x is less than -1. So got to scoot over to -1. Then I'm going to come down here to -3. Since it's not included, there's not a line under that, I would have an open circle at that point. And then it would continue as a straight line, horizontal line to the left. If that didn't make sense to you, we could still use the table. Again, the function is y equals -3. So if I pick an x value, so -1, again, because that's where the graphs change, numbers less than -1, well, that would be -2, -3. Y equals -3 as an equation means it does not matter what your x's are. Your y is always going to be -3. So for each of these x's, the y is always going to be -3. So if you plot -1, -3, -1, -3, that's where my open circle is. If I was to do -2, -3, I'd have a point there. -3, -3, I'd have a point there, so on and so forth. So even if you connect those dots, you still get the horizontal line. All right, for the other, so my equation is the negative of x squared plus 4. Make a chart. So again, I want to know what happens at -1. And then this function is used if x is bigger than -1. So 0 and 1, those will work out. All right, so we plug in a -1. So you're going to square -1. -1 squared is +1. But then that negative in front is going to change it back to -1. So this whole term right here is going to be -1. -1 plus 4, that's just 3. Plug in a 0, square it, it's still 0. The negative 0, still 0. So this thing just turns into 0 plus 4, which is 4. Plug in a 1. 1 squared is 1, but then it becomes negative when you apply this negative sign. So -1 plus 4, we get 3 again. All right, so at -1, 3. So -1, 1, 2, 3 right here. This is going to be a closed circle because it has the or equal to part underneath the inequality. 0, 4 would be right here, and 1, 3 would be right here. Now keep in mind you have an x squared. An x squared will always make a graph that looks like a U, either going up or going down. So that's the general shape. A parabola is what it's called. So I know this thing is going to make a U shape. So I'm going to, best I can, make a U out of that. And then I'm going to say it keeps on going down that way. And that takes care of the graph. All right. Is this a function? Again, at no point is it ever going to hit the graph in more than one spot. Keep in mind, it's okay that there are two circles here. This is not actually on the blue graph because it's not included. That's why it's an open circle. This one is, so there's still technically only 1 point on that vertical line when we get to this x equals -1. And then from there, no problems there. So yes, this is a function. All right, let's evaluate these for these three given values. So when x is -1, well, this is used when x is greater than or equal to -1, so I plug in here. -1 squared is 1, then apply the negative, it becomes -1 again. -1 plus 4, that's just 3. 2 is greater than or equal to -1, so again, I'm back in here. You're going to square 2. 2 squared is 4. The negative of that is -4. -4 plus 4, 0. So f of 2 is 0. -3 is less than -1, so I want to plug in here. And again, this is where it's just y equals -3. So if x is -3, y is also -3. There are your function values. All right, for number 4. Number 4, we're working with an absolute value equation. Absolute value equations basically make a V. So they look something like that. Or sometimes they go the other way and look like that. Some form of a V. That's what this thing will look like on a graph, okay? Now, we're only using a part of it. This is only used if x is greater than -3. So it may not be a full V. It may be just a part of it. So we'll just have to see what it looks like when we get it on the graph. Same thing. Set up our table. Once again, this is just the equation y equals -2. So that is a horizontal line through the y-axis at -2. But that only picks up if x is less than or equal to -3. So I would have the point if we do our table with that. So -3 and less than that would be -4, -5. The y value is always -2. So if I plot the point -3, -2, I would have a closed circle there. And then the point -4, -2 would have a dot there, there, so on and so forth. So my line goes this way. All right, that takes care of the first one. Now for the second one. So the absolute value of x plus 1. Get us a couple values to plot. Again, I do want to know what happens at -3, because that's where the functions change. And this occurs when x is greater than -3. We do want to be a little picky about the values we pick. Absolute value has to have a lowest point or a highest point, depending on the function itself. But that will always happen when you get a 0 in here. So what value would make this 0? -1, because -1 plus 1 is 0. So I do want to know what happens at -1. And then some other values that are less than -3, or greater than -3, I should say, excuse me, greater than -3. Let's just use 0. So if I plug in a -3, -3 plus 1 is -2. The absolute value of -2 is +2. So when x is -3, y is 2. Plug in a -1, -1 plus 1 is 0. Absolute value of 0 is 0. Plug in a 0, 0 plus 1 is 1. Absolute value of 1 is 1. -3, 2. So we go over 3, 1, 2, 3, up 2, 1, 2. This would be an open dot. -1, 0. So I'd have a point right there. And then 0, 1. I'd have a point right there. So this is going to give us that V shape right there. All right. So it would come down and connect like this. But then it's going to bounce back and go up the other way. There's your graph. And you can kind of see for that absolute value, you're kind of getting that V shape, but it gets chopped off here because this thing stops if x becomes less than -3. All right, is this a function? Again, vertical line test, have no issues. So yes, this is a function. Evaluating these for these given values. So plug in a -1, which is greater than -3, so it goes in here. So -1 plus 1 is 0, absolute value of 0, 0. 3 is greater than -3, so we plug in a 3 here. 3 plus 1 is 4, the absolute value of 4, 4. Plug in a -5, which is less than -3, so the y value is just -2. There are your functions. All right, the fifth one, now it's broken up into 3 pieces. So sometimes you got to have 3 charts, or 4 or 5. It just depends on how many pieces are broken up. But these we can still use 2 because this is that special case of y always being 1 between the x values of -2 and 3. So I'm going to start with the top function, -1/2 x minus 3. All right, so I want to make my chart for that. All right, so I want to know what happens at -2, because again, that's where things change. When x becomes bigger than -2, I'm no longer with this function. So I want to know what happens there. Now let's look at the function itself. We need to be smart about what values we pick for x, because anything I plug into this thing for x, I'm going to have to multiply it by 1/2. So I want to pick numbers that you can easily take 1/2 of. So even numbers. So I want to use negative numbers because my x's need to be less than -2, but they're also going to be even. So less than -2, the next even number would be -4, and then -6. So I want to take these values, plug them in here. 1/2 of -2 is -1. -1 minus 3, -4. 1/2 of -4 is -2. -2 minus 3 is -5. 1/2 of -6 is -3. -3 minus 3, -6. Okay? And then, again, this one, any x values you pick between -2 and 3, the y value is always going to be 1. So we're going to have that horizontal line through the y-axis at 1. So I'm not going to worry about a table with that one, but I am going to make a table for this 2/3 x. All right, again, I'm going to be smart about my x values. I still want to know what happens at the border. So at 3, where things change at 3, and anything I plug in here, I'm going to have to multiply by a 2/3. So I'm going to look at the denominator, which is 3. So I want to pick numbers that are divisible by 3. So numbers that are bigger than 3 that are divisible by 3. That would be 6 and 9. So if I plug in a 3 here, 2/3 times 3. So you're going to multiply the 2 times the 3 you plugged in. 2 times 3 is 6, but then that has to be divided by 3. 6 divided by 3, 2. I'm going to take this 6, plug it into the x. You're going to do 2 times 6, which is 12, but then that 12 has to be divided by 3, which is 4. And then 9, 2 times 9 is 18. 3 divided into 18, that would be 6. Okay, so let's start back here with the 1/2 x minus 3 on the graph. Notice your inequality is not underlined, so that means I'm going to have an open circle at this point, -2, -4. Open circle. -4, -5 is here, and then -6, -6 is here. So I can go ahead and connect those. So I get my line like that. All right, this middle piece between -2 and 3 on the x-axis, which occurs from here to here. Y is always +1. So I'm going to have a horizontal line here. 1, 2, 3 to here. So it's closed at the -2 because it's got the underlined inequality, but it's open at the +3, and it goes through the y-axis at +1. So there's the middle part of my graph. And then the last part, once again, I have a greater than or equal to, so I'm going to have a closed circle at this point, 3, 2. So over 3, up 2. So I'll have a closed circle right there. 6, 4 is going to be here. And then 9, 6 is going to be here. So your graph would take off like that. All right, is this a function? Again, vertical line test. It's never going to hit either piece of that graph in more than one spot at a time. So yes, this is a function. All right, evaluate these 3 values. So if x is 1, that means it's going to fall between -2 and 3. So that means the y value is 1. If x is -4, which is less than -2, that means I want to use this function. So I would plug in a -4. Half of -4 is -2. -2 minus 3 is -5. Plug in a 3, which is greater than or equal to 3. So that's going to go into the 2/3 x. So you're going to do 2 times 3, which is 6, then divide by 3 to get 2. There are your evaluations. All right, for number 6, another 3-piece. Again, I've got an absolute value function, so I know it's going to make a V shape somewhere. Here I just have a number, so I'm going to have a horizontal piece somewhere, and then just a 5 minus x, which would be a straight line somewhere. So let's just start with the absolute value of x plus 4. All right, so this changes when x is less than or equal to -3. That's the break point, so I wanted to know what happens at -3. And then I need numbers less than -3. So -4, -5. Again, since it's a absolute value, I want to know where this is 0, but that's going to be taken care of with -4. All right, plug these in. -3 plus 4 is 1. The absolute value of 1 is 1. Plug in a -4. -4 plus 4 is 0. The absolute value of 0 is 0. Plug in a -5. -5 plus 4 is -1. The absolute value of -1 we're back at 1. All right, again, I'm not going to worry about making a table for that middle one since it's just a horizontal line. But for this other one here, 5 minus x. So this changes over at x is 2, so I want to know what happens there. And then I use this if x is greater than 2, so I need numbers bigger than 2, so 3 and 4. Those will work. So plug in a 2, 5 minus 2, well, that's 3. Plug in a 3, 5 minus 3, that's 2. Plug in a 4, 5 minus 4, that's 1. All right, let's graph the absolute value part. So -3, 1. Again, -3 is where it changes. It's going to have a closed circle. So -3, 1, closed circle. -4, 0. Then -5, 1. So this is going to give me that V shaped. So we just connect this portion, get that little bit of an edge of a V, and then this for the other part. Again, it's kind of like a V that got chopped off. All right, for the middle part between -3 and 2, notice that -3, the inequality is not underlined, so I want to have an open circle at -3, 4. So -3, 4, open circle. And then at 2, 4, I would have a closed circle. And that's just going to make your straight line. And then last, the 5 minus x. So this thing picks up at +2, but it's not underlined for the inequality, so it's going to be an open circle at 2, 3. So over 2, up 3, open circle. And then 3, 2. And then 4, 1. So it's just going to go down like so. All right, is this a function? Does it pass the vertical line test? Yes, at no point is it going to hit either piece in more than one place at a time. So it passes, so yes, it is a function. Evaluating these values, so -3, well, -3 is less than or equal to -3, so I'm going to plug in here. -3 plus 4 is 1. The absolute value of 1, 1. F of 0, well, 0 falls between -3 and 2, which means the y value is just going to be 4. And then f of 6, well, 6 is greater than 2, so that means 5 minus 6, which is -1. All right, problem number 7, they gave me the graph. My job is to come up with the function. And then it also wanted me to state the domain and the range. Okay, so I'm going to start with f of x equals, this is 2 pieces, so my function is going to be broken up into 2 different rules. All right, so I'm going to start with the leftmost piece first. So I need to find the equation of this line. To write the equation of a line, you have to know things. What is the slope of the line? What is the y-intercept, or some point? If you know the y-intercept, the job becomes a lot easier because any equation, any linear equation, can be written as y equals mx plus b. So if I know the m and I know the b, I plug those things in, I have my equation. All right. So I'm going to start with the slope of this line. Remember, slope is rise over run. How far up and over to get from one point to the next. Notice this line from left to right is going up, so it's a positive slope. If I pick a point and another point and figure out up and over, well, that's just 1 over 1. So this line has a slope of 1. Where does this line cross the y-axis? Right here at 0. So it has a b of 0, 0. So I've got everything I need to plug it into the equation. So We're not going to put the y because the y is taken care of with this f of x. Remember, f of x is another way of saying y. So we have the y equals. I'm just going to put to the right of the equals. So my slope was 1. So 1x would just be x plus 0. Well, x plus 0 is just x. So I do not need to put the plus 0. So I'm not going to worry about that. So this line is of the form y equals x. That's the equation. And that's my rule. Now, when does this line work? When do we fall on this line? Well, I'm on this line if my x is less than positive 1. Notice, it's an open circle. So 1 is not included. So when I write the restriction, it's x less than 1. You do not underline. So if x is less than 1, I'm on the graph f of x equals x or y equals x. Okay? Now if I look at this line, this is the horizontal line. Horizontal lines are always of the form y equals some number. And that number is where the line would cross the y-axis. And if this one kept on going, it would cross the y-axis at 2. So this equation for this line is y equals 2. Now, what x values do I use this line for? Any values that are greater than or equal to, since it's a closed circle, 1. Again, we're not going to put the y equals because that's taken care of with this. So I'm just going to put the number 2. When do I use this? When the x is greater than or equal to 1. There's your piecewise function. Now, what's the domain and what's the range? Remember, domain is how far left and right your graph goes, and range is how far up and down your graph goes. So let's start with the domain. So this part of my graph keeps on going to the left, so it's going to approach negative infinity on the x-axis. So negative infinity. Here it stops, but then it picks right back up with this other line, so it's going to positive infinity. So my domain is all real numbers. The other way I told you could write that is from negative infinity to positive infinity. Either one of these would be a correct response. Now let's talk about the range. All right, your range is a little bit different because range is up and down, and on this graph I have some things happening. In terms of how far down will this graph go? Well, since this part of the graph keeps on going down and down and down, it's going to approach negative infinity. So I know it's going to negative infinity. And if I kind of think of it going the other way, so as I go the other direction, I'm fine with my y values until I reach this point. Notice this is an open circle, and the y value at this point is positive 1. But positive 1 is not included because it's an open circle. So negative infinity up until I get to positive 1. And since it's an open circle, I would have parentheses instead of brackets. Notice I jump from here to here, meaning between these 2 points right here, there are no y values. There's no part on my graph that's going to have a y value between 1 and 2. So we use the union symbol. Okay? This just means I have another part. So it goes from negative infinity to 1. Then I'm going to jump somewhere, and it's going to pick up. And it's going to pick up at 2. But I'm never going to go above 2. But 2 is included because it's a closed circle, and we have this horizontal line. So bracket 2. And that would be your range. All right, number 8. Here we have 3 different pieces. Okay, so my piecewise function is going to be broken up into 3 parts. So f of x equals, try and give myself enough room for 3 pieces. All right, again, I'm going to look at each piece individually. I'm going to try and figure out the slope. Hopefully I can figure out the y-intercept. If not, I'll have to do a different approach. Let's start with the furthest left piece first. Notice your line is going up from left to right, so that's a positive slope. If I pick up 2 points, I go up 2 over 1, so my slope for this line is 2 over 1 or just 2. If I kept going up 2 and over 1, notice this line would cross at positive 4. So it's going to have a y-intercept, or the b is going to be 4. So my equation of this line is y, nope, don't put the y equals, forgot about that, because the f of x, that takes care of my y, so I don't need the extra y. It's just 2x plus 4. And I'm on this line so long as my x is less than negative 1. All right, here we have a horizontal line. So it's just going to be y equals a number, and that number is where it crosses the y-axis, which is at 2. So this equation is just y equals 2. So for here, we're just going to put a 2, and that occurs when x is between negative 1 and 3. So lower bound is negative 1, upper bound is 3. So now we're going to fill our inequalities here. So if x is greater than negative 1 but less than 3, notice we got a special situation here. Those points, those two lines meet on the graph. So I'm going to underline the greater than inequalities for the second one. You have an option though. You could have underlined this one, but if this one was underlined, you're going to use negative 1 with this, then you would not underline this one. Okay, so you got some wiggle room here about what your inequalities may look like. For this third function, again, this one would have a slope. Since my line's going down from left to right, I know it's going to be negative, so up 2 over 1. So here my m is negative 2. Now, if I keep going up over 1, I'm going to get off my graph and I can't tell where it would cross the y-axis because it's too far up. So I'm going to have to do a little trick. I'm going to take the y equals mx plus b, and I'm going to use that to figure out the b. So if I want to use this to figure out b, that means I've got to have something to plug into the y, the m, and the x. Well, I already know my m. My m is negative 2. So I'm going to pick some other point on this line. Let's go with this one. So what are the coordinates of this point? Well, that's at 4, 0. So for x, I'm going to plug in a 4, and for y, I'm going to plug in a 0. So this becomes 0 equals negative 2 times 4 plus b. So now I can solve this to figure out the b. Negative 2 times 4 is 8. So we would have 0 equals negative 8 plus b. Then we would add the 8 to get the b by itself. So my b will happen at 8. So I get the equation, negative 2x plus 8, and that occurs if x is greater than 3. All right, for the domain and the range, so again, domain is how far left and right your graph would go. Notice this thing keeps slowly going to the left and slowly going to the right. So over time, all your x's are going to be accounted for. So all real numbers, or again, you can do the infinity, negative infinity. For your range, it's how far up and down. So in terms of going down, it's going to keep on going down to negative infinity. So negative infinity, but it tops off at positive 2. The y value is never going to be above positive 2. So it goes to 2 included because there are points when y is 2. So there's your range. And for the last one, so this is only a 2-piece function. So f of x equals. All right, this is that parabola shape, so it's going to be an x squared. All right, notice it was shifted down 2 points. So that means it's of the form x squared minus 2. And that occurs so long as x is less than or equal to 1. For the second one, my slope is going to be negative. If I pick 2 points on that line, I want to go up 2 over 1, so my slope is -2. It stops there. Let's see, I need the y-intercept. So if I kept going up 2 over 1, luckily it gives me a point on that graph, so it would cross the y-axis at 4. So this equation would read -2x plus 4, and this equation is used if the x is greater than 1. All right, domain left and right. So since this thing is still slowly spreading to the left, and this one is slowly moving out to the right, for your domain, you're going to have all real numbers. For your range, again, up and down. So this thing is going to keep on going up, and this one's going to keep on going down, even in this gap. So like this point right here, there are y values associated when x is 1 or anywhere between 1 and 2. So basically your range is also going to be all real numbers.